Dear students, this is part of the course Computer Architecture and Microcontrollers, and we have been seeing the programming of 8051 the last classes. So today's class we will be continuing with the programming of 8051. In this particular class we will familiarize with the command exchange. So let's go into the class. So the instruction for exchanging is XCH, and this instruction is used to exchange a byte of data. So that means 8 bit of data. Now let us see the syntax. The syntax is XCH a comma byte. So this byte can be in different locations. It can be a register or RAM location. So the command is XCH. So it's a simple. So we can find that this is the syntax. So it can be XCH. This is the destination. So and we have byte, which can be a register like RI, or it can be a RAM location. So this is the source. So we have an example to do. What is the content of the relevant registers before and after execution of XCH command? So the first instruction is move a comma hash 65. So this is an immediate data 65. It is moved to the accumulator register. And next one is move R2 comma 97. So this value R2 register gets a value 97. Okay. Then the next command is to exchange A and R2. So whatever value is there in A register, it will move to R2, and whatever value is there in R2, it will move to A. So accumulator will have the value 97H, and R2 will have the value 65H. So this is the meaning of exchange command. Now we will see what are the possibilities. So first one is using a register. So you can see here I have used exchange A comma R3. So whatever data is there in R3, it is exchanged with the contents of accumulator. So both will be interchanging the values. Next is you can use a direct address. So direct means you are using an address like so XCH A comma 50H. It means that the contents of 50H. 50H is a memory location. Whatever data is there in 50H, it is moved to A, and whatever data is there in A, it is moved to 50H. So exchange A comma 40. It means exchange A with data in the RAM location 40H. And the third option is register indirect, that is XCH A comma at Rn. So Rn is a pointer. So whatever data is there inside Rn, it is moved to accumulator, and whatever data is there in accumulator is moved to the memory location pointed by Rn. See, I've given some examples. XCH A comma at R0. So exchange A with data pointed to by R0. So R0 is a memory location. R0 is the address of a memory location, and that data is moved to A. And whatever data is there in accumulator, it is moved to R0. So these are some of the examples of exchange operation. Now let us do a. So here we have a problem. Assuming RAM location 40H has the value 97H, find its content after the following instructions. So here we can see the first instruction is an immediate move. So A will have the value 12H. Now the second instruction is move R1 equal to R1 comma hash 40. So R1 will have the value 40H. Now the third instruction is XCH A comma at R1. So what does it mean? XCHD means exchange nibble. Nibble means equal to 4 bits. So what happens is the lower 4 bits are exchanged. The lower 4 bits are exchanged. So here R1 is a memory location. So whatever is the data of R1, 40H. Now it is equal to 97. It is given in the question. So what this instruction does is it exchanges the lower nibble. The lower nibble of accumulator is 2 and the lower nibble of 40H is 7. So only the lower nibble is exchanged. So after the execution of the program, what we can find is A will have the value 17H and 40, the memory location 40 will have the value 92H. So only the lower 4 nibble is lower 4 bits are exchanged in XCHD. So this is a special type of instruction. So you have to note and study what is the importance of XCHD. It is used to exchange the lower 4 bit nibble. So I hope it is clear to you. So after execution of XCHD instruction, we have A equal to 17H and RAM location 40H has the value 92H. So what is XCHD? XCHD instruction exchanges only the lower nibble of A with the lower nibble of RAM location pointed to by Ri by leaving the upper nibbles in both places intact. The upper nibble is not affected. That is important. The upper nibbles in both destination and the source is not affected. Only the lower nibbles are affected. So you have to, this is a special type of instruction and you have to know that. So let us come to the summary of various data transfer instructions. We have seen every one. We have seen move. Different options are there for move. Then move X, it is to move from the data memory. That is move X. Move C, it is used for moving from the code memory or the ROM. Then we also studied about push instruction and pop instruction, and we studied about XCH and XCHD, exchange nibble. So important thing in this is no flags are affected. So we will see what are flags. One important thing is that none of the flags are affected by these instructions. That is a peculiarity of data transfer instructions. So please go through this slides. Thank you.